Okay. So, hi guys, how are you all? I hope all of you are doing good in these tough times of COVID and all of you are staying at your homes, taking care of yourselves. So, today, myself Khushang, I am the chemistry faculty at Altedemy. So, I am here to discuss about chemical kinetics, a short video on chemical kinetics based on your 12th boards exams. We'll be studying about what is actually chemical kinetics, why do we study chemical kinetics, what is the need. We'll be studying about the different rate of reaction equations and how to write rate of reactions, and we'll be studying two or three questions to that, and we'll be drawing graphs too. So not wasting much of the time, we'll be starting with chemical kinetics. So chemical kinetics is basically the study of the speed of the reaction and the basically the study of speed, right? You know, kinetic energy is related all about a moving object, the speed of a object half mv square. So similarly in chemical kinetics we study about the kinetics of a chemical reaction, in which how much fast the chemical reaction is, when it will get completed, as we have studied everything of the chemical reaction, starting with the formation of molecules to compounds to reacting other compounds, breaking bonds, forming new compounds, studying about chemical reactions, spontaneous reactions, non-spontaneous reactions, exothermic reactions, endothermic reactions, every type of reactions, homogeneous, heterogeneous, every type of reactions we have seen. We have studied about the chemical reactions in very great depth. Now what the question was left is that we have studied about this chemical reaction, we have studied everything, that it is endothermic, it's delta G is this, it is spontaneous, it is this, everything. Then it is at equilibrium or not, everything. Then we just ask the question, in practical life, when this reaction will get completed, when this will happen. These all questions are answered by the chapter chemical kinetics. For example time, whenever one second, I'm sorry. So whenever the your parents tell you that a diamond is forever, so they tell you to invest in diamond or gold itself, or gold is a metal, it is good. But if they tell you that diamond, if there is a diamond, it is forever, why do they tell it? Actually this statement is a wrong statement. Why it is a wrong statement? Diamond gets converted into graphite. When does it get converted? It takes thousands and thousands of years. Thousands of years to convert. So this reaction is very slow, it is a very long reaction. So that's why when the parents and their parents and their parents and their parents live, they it doesn't get affected, the diamond stays itself. But in a very large amount of time, the diamond will get converted into graphite. On the other hand, because you know that this graphite is a form of carbon and diamond is also on the other, it is a chemical reaction. On the other hand, if there is water here and we mix a drop of ink in it, right? So it gets it the ink changes the color of the water in seconds. In seconds. Both are chemical reactions, but one is getting converted is getting completed in thousands of years, and one is getting converted in seconds. Why? What is the difference? Both of them are the chemical reactions. So this was the need of studying chemical kinetics, right? This was the need of studying chemical kinetics. Actually now we will study chemical kinetics at a level called as molecular level. Molecular level. We will be seeing the reactions at molecular level. This is important. Actually, when we were talking about reactions, seeing reactions to happen, seeing endothermic, exothermic, these things, actually you can consider that you were a bird and flying over a city, and you were watching the city downwards, and you were seeing that there are buildings there, there is a road there, there is a house there, and all of that, right? Now at a molecular level, when you are studying chemical kinetics, you are diving into the chemical reactions. That is, you are diving into that house, and you are entering the house, and now you are seeing where is the kitchen, where is the lobby, where is the bedroom, everything. Now this is the molecular level. We study chemical kinetics at a molecular level, and we study about how fast or how slow the reactions will happen, what is the rate of chemical reaction, how we can measure the speed of the chemical reaction, how we can measure when the reaction will get completed, how we can measure the half life of the chemical reaction, everything like that. I hope you guys have studied it all, and you are just revising the subjects as your boards are coming nearer and nearer. So okay, so we'll move ahead. So we'll be talking about some physics, right? Some physics concepts we'll be talking about. The first concept is, if there is a road here, and this is a road, and there is a car moving there on the road. There is a car, right? It is moving there. There are many obstacles here, here. So the car moves, then stops, then moves, then stops, then moves, then stops, and continues like that. So if we draw the distance versus time graph of this car, that is, this is the distance, this is the time. If we draw the distance versus time graph of this car, what we get is, the graph is like this. Okay, so now we have two types of speeds. We have two types of speeds: instantaneous speed and average speed. For example, the graph gets completed here, and the time and the distance, so d and t. For example, the car gets stopped, so average speed, if we calculate average speed for this car, will be equal to total distance divided by total time taken, right? It will be equal to d by t. Simple. But if we calculate the instantaneous speed of this car at this point, so we'll be drawing a tangent here, we'll be meeting the x-axis here, and we'll be calculating the slope will be equal to d distance by dt, right? You have studied all this in your kinematics chapter, right? So similarly, we have average, so average speed was equal to delta d by delta t, and instantaneous speed was equal to d by dt, right? So, or you can say dx by dt. For example, x is the distance, right? Delta x by delta t, or dx by dt will be the instantaneous speed. So now we'll be talking about the rate of the chemical reaction. What is the rate of the chemical reaction? Rate is basically measure of how fast the chemical reaction is happening. So rate is the measure of how fast the chemical reaction is happening. One second. Okay, so if we write the definition of rate of chemical reaction, if we write the definition of rate of chemical reaction, it will be the reaction rate, or the rate of reaction is the speed at which a chemical reaction takes place. Takes right. It is defined as it is proportional. It is proportional to the concentration of product per unit time and to the यहाँ पे here decrease will come, oh sorry, increase in concentration of the product and to the decrease in concentration of reactant per unit time. What is it saying? It is the speed at which a chemical reaction occurs, right? So it is proportional to the increase in the concentration of products per unit time. So if there is a reaction happening, and the reaction happening is R going into P and P going back into R. So obviously when the reaction starts, the product's concentration increase and the reactant's concentration decrease. So the rate of change or the rate of increase of concentration of the products is the rate of the reaction, or the rate of decrease of concentration of reactants is the rate of the reaction, which will be equal, right? You're understanding? The rate at which the reactants will get depleted will be equal to the rate at which the products will be getting formed, right? So rate of the reaction is proportional to the increase in the concentration of product per unit time and decrease in the concentration of reactant per unit time. So if we write there is a reaction R is to P, the reactants concentration will be taken as R and products will be P. Okay, so if we calculate the average rate of the reaction, there are two types of rates, average rate and instantaneous rate, similar to the average speed and instantaneous speed. So if we write the average rate of the reaction will be equal to delta concentration of reactant by concentration of time will be equal to delta P by delta T, right? And as we know that there is a decrease, so delta R, that is the final concentration of reactant minus the initial concentration of reactant, will always be negative because the reactant's concentration is constantly getting decreased. So we'll add a minus sign here. I hope you got it. Why we added the minus sign? Because the reactant's concentration is getting decreased and the product's concentration is getting increased. So obviously after a short amount of time, the final concentration of reactant will be lesser than the concentration of reactant before that time. So if we subtract R2, if we take the final concentration as R2 and initial concentration as R1, so if we subtract R2 minus R1, there will be a negative sign. It will be a negative quantity. So we add a negative sign in the front of reactants only. Reactants only. So this is how we write delta. This is how we write the equation for average rate of the reactants, and it can also be written as negative of, if we take these brackets, R2 minus R1, this bracket close, and delta T, which will be equal to P2 minus P1 divided by delta T. So this is how we write the average rate of the reaction. I have told you how why we write the negative sign in case of reactants. Now we'll study about the instantaneous rate of the reaction. instantaneous rate of the reaction, right? So as we saw that when we wrote about the instant average speed was equal to delta x by delta t, and instantaneous speed was equal to dx by dt, right? So similarly, when we'll write about the instantaneous rate of reaction, what will be it equal to? It will be equal to d concentration by dt, right? So we write rate instantaneous will be equal to minus of dr by dt will be equal to dp by dt. I hope you got why we wrote the negative sign in case of reactants. I have told you already. Will be equal to the slope of concentration versus time graph. So the slope of concentration versus time graph gives us the instantaneous rate of the reaction, right? So if we write, what will be the unit of rate of reaction? Unit of rate of reaction. What will be the unit of rate of reaction? As we know that rate is equal to the concentration divided by time. So concentration unit is molar. Molar will be equal to mole per liter, right? And time is equal to second. So it will be equal to mole, liter inverse, and second inverse. This is the unit of rate of reaction, right? I hope you guys got it. And this concentration of mole per liters is everything in the case of liquid reactants. When we have a concentration, when we have a solution of reactants and they are getting solved, and we have the rate of, but if we can also calculate the rate of reactions in case of gases. So in case of gases, when we write rate, here we write the pressure change divided by time. So what will be the unit of rate of reaction? It will be equal to, pressure's unit is atmosphere upon second. So it will be equal to atmosphere per second in case of gases, right? I hope you guys have got it. We'll be moving ahead. So we have seen how we write the rate of reactions and how we write the expression for rate of reactions. Now we'll be solving 2 or 3 questions. This was a short video all about. We were able to solve what is rate of reaction and how we can write the rate of reactions and what is the expression of rate of reaction. So now we'll be solving 2 or 3 questions. So rate of reaction. First question. First, we can write rate of reaction. We have 2 types of equations. Equations are of 2 types. First type is where the stoichiometric coefficient is equal to 1, and other where the stoichiometric coefficient is not equal to 1. So here for example we can write HGl plus Cl2 will be giving HgCl2. So all of these, the stoichiometric coefficients are 1, 1 and 1. So if we write the second example where the stoichiometric coefficients are not equal to 1, stoichiometric coefficients are not equal to 1. Example is Hi is going into H2 gas plus I2 gas, and the stoichiometric coefficient here is 2. So rate of reactions expression will be different for these types of reactions and will be different for the other types of reactions. I'll be just telling you what we'll be writing. We will not be going into the depth of the reaction as it is a short video, and I hope you have solved it. I will be just revising how. So the first example was Hg plus Cl2 will be going into HgCl2. So we have to write the rate of the reaction. What is the rate of the reaction for this equation? Rate of reaction will be equal to minus of, as it is a reactant, so minus of delta change in the concentration of Hg divided by delta T will be equal to minus of, again a reactant, delta change in the concentration of Cl2 divided by delta T. Again, now in terms of products, if we write, so it will be a plus. So delta HgCl2 divided by delta T. All of the stoichiometric coefficients are 1. So this is our correct answer. Now we will be solving with non-unity stoichiometric coefficients. So second example is N2 plus 3H2 will be equal to 2NH3. Now we will write the rate of the reaction for these type of equations. What will be the rate of the reaction? First, N2, no stoichiometric coefficient, it is a reactant, will be equal to minus delta N2 divided by delta T will be equal to delta minus again and delta H2's concentration divided by delta T. But for 1 mole of nitrogen, there are 3 moles of hydrogen present, right? So how we can measure the rate of the reaction? How we can measure the rate of the reaction which will be equal to 1 mole of reaction? If we have the rate of the reaction in which 1 mole of nitrogen is getting changed per unit time, which is equivalent to change in 3 moles of hydrogen per unit time. So for calculating 1, we will be dividing it by 3. Its stoichiometric coefficient will be equal to, again, delta NH3, as it is a product, so we will not be writing the negative sign, will be divided by delta T. Then again a stoichiometric coefficient is present before NH3. So for 1 mole of nitrogen, there are 2 moles of NH3. So we'll be dividing, for 1 mole of NH3, we will be dividing the rate of the reaction by its stoichiometric coefficient. So this is the way how we write the rate of reaction for non-unity stoichiometric coefficients reaction. And this is the shortcut. We have studied the proof in great detail in our long videos, right? So this was the short video all about. I hope you guys have got it, what is the rate of reaction, what is the expression for rate of reaction, how do we write rate of reactions for the reactions having stoichiometric coefficient 1 and non-unity stoichiometric coefficients reactions. You have got it. You can solve the answers. So that's it for today. So till then, keep studying. Bye bye.